Hello. In this video, I just want to make some comment about the Gaussian elimination algorithm, or just the algorithm to get a matrix into echelon form to solve a system of equations. And the point I'm trying to make in this video is that it is an algorithm. It's something that you do that works no matter what your matrix is. So it's not like you look at one matrix, excuse me. It's not like you look at one matrix and say, okay, I'm going to do one thing, and then you look at a different matrix and do something else. You do the same procedure for every matrix. And this might be not what you're used to. For instance, let's say you wanted to solve this system. Negative x plus 4y equals 7, 9x minus 4y equals 9. Let's say you had something like this. Now, what you would probably do, okay, if to solve this is, so what you would probably do do you see a quick way to do this? You can add the 4y and the negative 4y. If you add these two equations, the y's will cancel, right? So I have, remember, x and y are numbers. So the left-hand side is a number, right? This number is 7. This number is 9. These two numbers are equal. These two numbers are equal, so I can add the equations. If I add that plus that, I'll get that plus that. And the benefit of adding the equations is that the y terms cancel. So if you add the equations, then you get this new equation, which is 8x equals 16. And then you divide both sides by 2, and then you get x is 2. Okay. And sorry, just getting distracted. So x is 2, and can you figure out what y is going to equal? You just plug it into either of the equations. Let's just plug it into the first one. And then I'm going to get 4y is equal to 9, and then y is equal to 9 over 4. So the answer is 2, 9 over 4, right? That's my solution. X is 2, y is 9 over 4. But if you wanted to do this using Gaussian elimination, which I'll abbreviate as GE, then what you would do is you would set up the augmented matrix, and the augmented matrix is this. Right? Yep. And you want to get this 2 by 2 part, the coefficient matrix, into echelon form. And there's an algorithm for this. Now, what we did above would correspond to, say, replacing row 2 by row 2 plus row 1. And then that'll give you a 0. See, if we did the row operation, row 2 goes to row 2 plus row 1, then we would get this, right? But is this matrix in echelon form? No, right? It's not in echelon form. This matrix is not in echelon form. So the steps, the point I'm trying to make is that the steps to doing the algorithm is not necessarily corresponding to the step that you would naturally do to solve a system of equations. Okay? So this is something that I've noticed, that sometimes students will, when they see something like this, and they're asked to get the matrix into echelon form, they'll do this step because it's the natural kind of thing to do. That if you had a system of equations and you wanted to solve it, you would just, add them, and that would be something like replacing row 2 by row 2 plus row 1. But you don't get a matrix in echelon form that way. And the point of the algorithm is to get your coefficient matrix into echelon form. So what is the correct algorithm step? It would be, well, you could divide, there are variations of the algorithm. So one way would be to divide row 1 by -1 to get a 1 as the pivot. But if you just wanted to get the echelon form without necessarily the pivots being 1, then you would replace row 2 by row 2 plus 9 row 1. And that will give you, so if you multiply row 1 by 9, then you're going to get a -9 on the top, and then when you add it, you get 0. Then you get 36 minus 4 is 32, and then 63 plus 9 is 72. Now your matrix is in echelon form. And if we wanted to finish solving the system, then we would divide row 2 by 32. So maybe 1 over 32 times row 2. By the way, the notation I'm using for the row operations might not match the notation in other books. Okay, so you get 72 over 32, which turns out to in fact be 9 over 4, as we would expect. And then the next step is, I guess we could have made the pivots equal to 1. So you would divide row 1 by -1. Multiply row 1 by -1, that gives you this. We could have done that first, actually, before. The point is to get the pivots to be 1. And then the last step is to replace row 1 by row 1 plus 4 row 2. And that will give you this. And so x is 2 and y is 9/4, which matches what we got above. So you see, this is the correct way to do it if you're doing the Gaussian elimination algorithm. And it's much more steps than the kind of natural way to do it with equations. Okay, but if the point I'm trying to make is if you have like a 4x4 matrix, you have four equations and 4 unknowns, and you set up the augmented matrix, generally speaking, you shouldn't be looking at different parts of the matrix to figure out what to do. Okay, it's not like a puzzle. There's an algorithm. You do the same thing no matter what your matrix is. So you shouldn't be looking for shortcuts. You shouldn't be trying to do any of that. Oftentimes, those things don't get your matrix any closer to echelon form. So when you have a matrix, you want to do the same thing for every matrix to get into echelon form. That is, you start from the left column, you look at your top left entry. If it's 1 or non-zero, if it's not 1 and you see a 1 below, you could swap rows to get a 1 at the top, or you could just scale the row by a number to get a 1 on the top left. Or you don't necessarily have to get a 1 on the top left, but it might make the calculations easier. Anyway, you need a non-zero number on the top left, If it's a 0, then you need to swap rows, right? If the whole first column is 0, then you start with the second column. And once you have a top left number that's 1, then you, or non-zero, then you use that row to get everything below it to be 0. And then once you're done with that, you proceed to the next column. Okay, you have a number that's non-zero, you get everything below it to be 0, and you keep going until you get to the end, and your matrix is in echelon form. That's the algorithm, basically. So make sure that you're actually doing the algorithm and you're not kind of doing different things for different matrices and looking at the, bottom right or the top right or anything like that. You want to start from the left and go down and then keep going until you get to the end, because that's the algorithm that you're using. Okay. So for instance, to reduce this matrix here to echelon form, as I said, you would do this step, not this step. Okay. So just keep that in mind when you're doing these computations. That's all I wanted to say in this video. Thanks.